In this lesson today, we do 13.3 apportionment method. Okay, apportionment method. And the question is, what is apportionment? What do you guys think? What is apportionment? Let me talk about apportionment, then let's talk about the method. Okay, apportionment method. Apportion. Apportionment. Apportion means you divide. Divide a quota. Okay, I'll mention later what is quota going to be. Also called allocated item. Allocated item among the group. Among the groups. Okay, based on the population of the group in proper way. Proper way. Not randomly, but there is with the rule. Proper way means what? With some rules. I should say with some rule. That is called apportion. The apportion means you divide the number of item among the group based on the population. And you can think about the US Congress, right? Oh, House of Representative, and Florida has, I think, 29 House of Representative, but Wyoming has only one. Why? Because the population is different in here in Wyoming. Therefore, you have different number of representative for different group. Here, Florida is one group kind of example. Every state is like a group. Therefore, based on the group population, you divide the item among the group proper way. That is called apportionment. And I say it's with the some rule. Okay, some rules. Therefore, there is a couple of rules for the apportionment method, and there is a 4 rule. Let me write down the rule here. It's called apportionment method. And this method include, number 1 is Hamilton method. Hamilton method. Number 2 is Jefferson method. Number 3 is Adams method. Number 4 is Webster method. Okay, number 4 is Webster method. And I do each, I should say, this Hamilton's method, Jefferson's method, Adams method, Webster's method. Okay, and these are the 4 methods we use to divide the quota. Again, we use the word quota or allocated item, the same thing, among the group in proper way. All right, and in homework, the question tells you, hey, use Hamilton method or use Jefferson method or use Adams method, and you have to use the method that the question asks to use. Okay, all right, that's the apportionment definition, and the method for the apportionment are those 4. All right, now to do the apportion, we have to define the 2 term here called standard divisor. STANDARD, standard divisor. Standard divisor and standard quota. STANDARD, standard quota. Okay, STANDARD, standard quota. Okay, there's 2 terms involved in the apportionment method. Basically, in the Hamilton method, we use standard divisor and standard quota. Okay, what is standard divisor? How do you find the standard divisor? Let's do that. Okay, there's a formula for it. Let me write the formula. Standard divisor, I put the STD for standard, divisor. Standard divisor equals to total population divided by number of allocated item. Okay, number of allocated item. That is same as quota. ALLOCAT, allocated item. That's the formula for standard divisor. To find the standard, again I put STD for standard. Standard divisor, you divide total population. That means you add all the group population. That's how you get the total population divided by number of allocated item. Okay, that's the standard divisor. And standard quota, I should say STD for standard, QUOT, quota. Standard quota is, the formula for standard quota is population of a particular group divided by standard divisor, divisor. That's the standard quota. Standard quota can be obtained from each group. We do the example. First questions in the homework is how do you find the standard divisor and how do you find the standard quota for each group. Okay, I should say standard quota for each group. Okay, whatever number of the group, you have to find the standard quota for each group by using this formula, the population of the particular group divided by standard divisor, which we find before. Okay, that's the two formula we're going to use in this section. And these two are only used in Hamilton method. Okay, not other method. Hamilton method. And what do you use for other method? I'll talk later. But only in this method, Hamilton method, we use standard divisor and the standard quota. Other three methods, we use different types of divisor. We'll mention later. Okay. Okay. Now let's do question number 1. Question number 1. Read the question carefully. Look at here. A large hotel chain need to apportion 24 new surfboard for its visitors to rent among 3 hotels based on the number of rooms in each hotel as shown as below. Listen, there is a 24 item to be apportioned. Therefore, 24 here is number of allocated item, right? Because you want to apportion 24. See, a large hotel chain need to apportion 24. Therefore, 24 is number of allocated item, right? 24. And this 24 has to be divided into 3 hotels, A, B, C. These are the group. Hotel A, one group. Hotel B, another group. Hotel C, another group. And each hotel has a number of room. It's like number of room is the population, not actually the person here, because you want to divide this 24 surfboard. Remember that number of allocated item 24, which are the surfboard, among 3 hotel based on the room they have. Therefore, here number of room is the population here, and total number of room among 3 hotel going to be 672 rooms. And the first question is, what is standard divisor? Okay, and we had the formula we just had it before. What's the formula for standard divisor? The total population divided by number of allocated item. Therefore, let's find the standard divisor here for part A. standard divisor equals to total population. Let's do directly. Total population is 672 divided by number of allocated item 24. Okay, and if you divide 672 by 24, that's going to be 28. Okay, therefore the what is the standard divisor? Answer is 28 is the standard divisor. Everybody okay so far? Okay, good. Now for part B, find the each hotel standard quota. Listen, that's the second question here. And see, I mentioned before standard quota for each group. That means in this case for each hotel standard quota. For standard quota for hotel A, standard quota for hotel B, standard quota for hotel C. You're looking for standard quota for each hotel and round it to nearest hundredth. Remember that hundredth, nearest hundredth, you rounded that. This is the 2 decimal places. Okay. Therefore, how do you find the standard quota for hotel A? What's the formula? Listen, that's the formula here. A standard quota is population of the particular group divided by standard divisor. Therefore, you divide the population of hotel divided by standard divisor. Therefore, what are you going to do here? To find the standard quota for hotel A, you do this. For this one, you do 305, you divide by 28. Okay, if you divide 305 by 28, let's see what's going to happen. I divide 305 by 28, it's going to be 10.892. Therefore, if you round to 2 decimal, 10.89. For standard quota for hotel B, you do the similar. You divide 214, which is the population of B, the group B, divided by 28, and round it to 2 decimal places, you get 7.64. Okay. For standard quota for hotel C, you divide again 153 by 28. That gives you 5.46. Okay, that's the standard quota for each group, or here each hotel. Does it make sense what I'm saying here so far? Therefore, question number 1 is finished. Question number 2. A small country is comprised of 4 states A, B, C, D. Remember that country has a 4 state. Like we have a 50 state, one country has a 4 state A, B, C, D, and each state is a group here, and the population of each group is 52,000. Remember that, 52 in thousand. 128,000. C group population 224,000. D group population 246,000. Total population 650,000. Okay. Again, you have 650,000, but you don't have to write that because it's in thousand. According to the country constitution, the Congress will have 465 seats. Remember that. Now you're looking for politics here. 65 seats. Therefore, 65 is number of item you want to divide. Okay. Read the question carefully. I'm sorry, my computer is frozen here. Okay. 65 seats divided among 4 states according to the respective population. Okay. Therefore, you have to divide 65 number of quota equals to 65, and you divide the 65 quota among these 4 states according to the population. And the first question, part A, is find the standard divisor in thousand. How many people are there for each seat in Congress? That's the second part of the question. There's two boxes. You can see that. First question, find the standard divisor. Second question, number of people in each seat. Remember that there is 65 seat, right? Okay, let's do the standard divisor. For this one, let me do here. Standard divisor, STD, DIVISOR, divisor. Standard divisor equals to total number of population 650 divided by number of quota at 65, who is going to be 10. Therefore, pretty much 10,000. Therefore, since we are writing answer in thousand, but question says already in thousand, therefore you're not doing 10,000. You just write 10. That's all. 10 is already in thousand. Therefore, you just type 10 here. Okay. Number second part of this part A, number of people in each seat. Remember that there is 650,000 people, and each one seat equals to 10,000 people, right? Remember that one seat equals to 10,000 people, two seats equals to 20,000 people. So you can see that 65 seat equals to 65,000 people. Therefore, the question is number of people for each seat. Remember that for each seat, number of people for each seat, one seat is 10,000. That means pretty much 10,000 people is represented by one Congress, one representative. That's what we call. That means 10,000. In other words, one Congress, CONGRESS, Congress people, wherever man or woman, Congress people, equals to 10,000 people. Not one Congress people, one Congress person, whatever, one Congress, one representative, let's write one representative. Okay, one representative equals 10,000 people. In other words, you can see that 65 representatives have 65,000 or 650,000 people. Okay, that's total population. That's the part A. Part B, find each state standard quota. Remember that one is done for you. Two of them have been done for you. We can see here, two of them have been done for you. This two done for you. You can see that 5.2 and 24.46, they are done for you. Now let's find the standard quota for 128. What's the standard quota for B? How do you find it? 128 divided by 10. This gives you 12.8, right? The answer is 12.8. What's the standard quota for C? For the standard quota for C, let's see here. For the C, 224 divided by 10. Notice that 10 here is standard divisor. Okay, which gives you what? 22.4. 22.4. Okay, that's how you find the standard quota. Remember that we did that before as well. That's how you do standard quota. Now listen, now next part, find each state lower quota and upper quota. Listen, for state A, what's the standard quota? Standard quota are going to be, for state A, standard quota are going to be 5.2. Okay, if you round it up, going to be 6. If you round it down, going to be 5. This is called upper quota. Upper quota. This is called lower quota. Lower quota. Therefore, if you round it up, that's going to be upper quota. If you round it down, that's going to be rounded quota. Rounded down, lower quota. Therefore, you have for state A, 5.2 rounded up to 6, rounded down to 5. Therefore, for A, 5 is lower quota, 6 is upper quota. For B, 12.8 is standard quota, 12 is lower, 13 is upper. Okay. For C, 22 is lower, 24 is upper. Oh, sorry, 23 is upper because 22.4. For D, 24 is lower, 25 is upper. Okay. Therefore, this lower quota, upper quota is a whole number. You guys notice that lower quota, upper quota are whole number, but standard quota is a decimal. Okay, note here, always careful. Note standard quota is a decimal, but upper quota and lower quota has to have a whole number because you round it either up or down to get the whole number. That's the lower and upper quota. Does that make sense? Okay. Okay. Question number 3 and 4 are similar because both are Hamilton method. Hamilton method. Uh, Hamilton method. But since question number 3, one of them is done for you. Okay, this B already is done, but in number 4, nothing is done here. Therefore, it's similar. It doesn't matter for me, but I'll do question number 4. Okay, I'll do question number 4. Question number 4. A university is comprised of 5 schools, A, B, C, D, E, 5 schools. And enrollment in each school is given in the following table. Remember that this population is enrollment for school A, school B, school C, school D, and school E for the university. There are 300 new computers to be apportioned. Remember that 300 new computers to be apportioned. Therefore, number of allocated item is going to be 300, right? Because you want to divide 300 computer among the school. A number of allocated item 300 because you want to apportion 300 new computer among 5 schools according to their respective enrollment. Use Hamilton method. Therefore, the question is use Hamilton method to apportion this 300 computer. Okay, I want to make new table because in this table the final answer goes in the box, but I'm going to draw the same table here and you guys see how I'm gonna do the problem. But here in the box I put the only final answer here. Okay, but before I have to draw the table, redraw the table. But in the meantime, can one of you add this all 5 number? Tell me what's the total population gonna be. Can you somebody adding please? And you see that I rewrite the table. Okay, and I leave a little bit bigger column here because I need more row in the bottom. That's why I leave the I make this bigger column here. The total number of people or enrollment going to be 10,350, correct? 10,350. 10,350. 350. Okay. Now, my question is, which school got how many computer? Remember that 300 computer need to be divided. Okay, 300 computer need to be divided among 5 school. Yes, CHOO schools. But which school got how many computer? That's what I'm going to do by using Hamilton method. Okay. All right. Do you understand the question? Therefore, you divide the computer among the schools using Hamilton method. Okay. I mentioned before, if you guys remember that, I use standard divisor and standard quota only in the Hamilton method. Therefore, I have to find the standard divisor first. Let's find the standard divisor. What's the formula for standard divisor? How do you find it? Standard divisor. Let's find it. I need that. Standard divisor is total population. STD, standard divisor, equals total population 10,350 divided by 300. Rounded to 2 decimal. Let me do the math here. 10,350 divided by 300, which gives you 34.5. 34.5. Okay. Now, what I'm going to do here is for each group, I got to find standard coda. That's the next step. Okay. How do you find the standard coda? For standard coda for A, standard coda for A, school A, how do you find it? You divide 1140 by 34.5. Okay, let's see what you get. 1140 divided by 34.5. I get 33.04. 33.04. 33.04. Okay, and now how about the other number? You do the same thing for each one, and you guys do by yourself, I do by myself, and we'll check, double check. Okay, let's see. Now we find the standard coda for each group by dividing group population by standard divisor, which is 34.5. Now next row, what I'm going to do is I have to round down standard lower coda. That's why I got to find it. Standard lower coda in the Hamilton method. Standard lower coda. Standard, next row going to be standard lower coda. Okay, let's see. Lower coda, doesn't matter whatever decimal is going to be, always lower. Okay, this 33.04 becomes 33, 36.23 becomes 36, 61.74 is 61, not 62, because we are lowering down. Standard lower coda. Okay, doesn't matter whatever decimal points after decimal, whatever number after decimal is going to be, always lower down. And this 84 here, 84 here, that's called standard lower coda. Everybody okay so far? Okay, now can you add 33 plus 36 plus 61 plus 84 plus 84? How much total gonna be? I will add by myself, you guys add also. Let's see how much gonna be all together. 61 plus 84 plus 84, I get 298. Do you guys 298? I think you have.
Yeah, I got 298.
Thank you. All right, listen, pretty much what it looks like here is A got 33 computer, B got 36 computer, C got 61 computer, D got 84 computer, E got 84 computer. Total number of computers divided is 298. Oh my God, how about the two computer? How many computers need to be divided? How many? 300. Therefore, if you divide it that way, two computer is surplus here. We call two surplus. Surplus item, right? Therefore, in the Hamilton method, you have a surplus item going to be there, because remember that basically we assign the computer for each group as a whole number, but remember that 300 computer need to be divided, but we only divided 298 computer, still two computer left. The question is, who will get those two computer? That's the question. Which group got those two computer? What do you think? Okay, here's the rule. The Hamilton is that's the Hamilton here. You give surplus item one at a time to the group which has largest fractional part. All right. Okay, do you understand what is fractional part here? Look at here. Which has the largest fractional part here? Look, what's this 74? This is the largest one, right? 74 here. That's the largest one here. After decimal, that's the fractional part. Okay, therefore you add one computer to C. group. Therefore, you put +1 here. For 61 now has to be 62. Therefore, pretty much C got 62 computer. And which is next largest fractional part? What do you guys think? Do you guys say next largest fractional part? 64 here. Therefore, you add 1 more to the group E. And therefore, technically, you have 62 for group C, 62 for group C, and 85 for group E. And again, A has 33, B has 36, D has 84, and total number is 300 total, correct? Because we add 2 extra to the group which has the largest fractional part. Remember that, 1 at a time. You cannot give 2 at a time, okay? 1 at a time. And the answer, you go back here, then you put the final answer. Then A has how many computer you found? 33 computer. You can see that it has 33 computer. B got 36 computer. C got 62 computer. You see here. And D got 84. E got 85. And total number of computers is 300. That's what we want to apportion among the 5 school. That's how you do Hamilton. This is called final apportionment by the Hamilton. This is the final answer, okay? But remember that to get the final answer, you have to do step by step. So you got to find for the standard coda and standard lower coda, and you have a surplus. You got to divide. You got to give the surplus to the group which has the largest fractional part. Okay, do you guys see what I'm saying here? That's called Hamilton method. That Hamilton is harder than other one. Other one is piece of cake, very easy one. But Hamilton is a little bit more, but not that difficult either, because you just do what? Divide and distribute the coda to the group. Okay, I finished the Hamilton method. Next method is Jefferson method. And Adams-Webster, very easy method. All 3 methods are easier, okay? But only Hamilton method is difficult. Okay, next method is Jefferson. Okay, I mentioned before. Only Hamilton method uses standard divisor, but these 3 method. These 3 method use different divisor. Okay, these 3 methods use. These 3 methods use modified divisor, MODIFIED, modified divisor. Okay, you know how to find the standard divisor, right? But modified divisor, you don't have to find it. That is given for you guys. Just that is given. Just use it. Therefore, all 3 methods we use modified divisor. You don't have to find it. Every time the question has a modified divisor is given. All right, now let me go back to the question here, and let's do question number 5. It is very simple. It's easier than other Hamilton method, because divisor is given. There is no surplus gonna be. Let me do this question, and you understand what I mean here. Okay. All right. Okay. Okay. A large hotel chain need to apportion 35 new surfboard for its visitor to rent among 3 hotels. There is 3 group here, and apportion 35 new surfboard. Now, number of code are going to be what? Number of allocated item is 35. Okay, 35. Right, and number of group is ABC, and total number of population is 1085. Here total number of population doesn't matter, because in the Jefferson method we're using Jefferson method. See here, Jefferson method, not Hamilton. Only Hamilton use total number of population, remember that, to find the standard divisor, but Jefferson doesn't use that. And it tells you find modified coda. Modified coda. Like we find the standard coda, we have the modified coda here. And that tells you, hey, use the divisor 29.8. Look at here. Look at here. Do you see the number here? 29.9, 29.8. That's number here, 29.8 is modified divisor. The modified divisor. Right. The modified divisor. If you want to find the standard divisor, you could, but you don't have to. You know how to find it, right? But you are not supposed to find it here because you are not using Hamilton. Only Hamilton use standard divisor. The modified divisor is given. That's why you see every questions, the modified divisor is given, you just use it. Okay, similar idea as before. How do you find modified coda here? Let me write down here for question number 5, modified coda for A. The modified coda for A. Modified coda for A. How do you do the same thing? You divide 316, total number of room, that's the population of the group A, hotel A, divided by 29.8. You use modified divisor, not the standard, because again in the Jefferson, Adams, Webster method we use a modified divisor. Therefore you use modified divisor. 316 divided by 29.8. Let's do the math here. 316 divided by 29.8. 10.60. Okay, 10.60. Rounded to 2 decimal places, near it 100th. Therefore it's going to be 10.60. Same for modified coda 4B. For B, how do you find it? What's the B population? 211 divided by modified divisor 29.8. 211 divided by 29.8. Get 7.08. 7.08. 7.08. The 4C. What's the modified coda for C? 4C. 558 divided by 29.8. Okay, 558 divided by 29.8. 18.72. 18.72. Okay, now listen. That's the modified coda. Remember that, like standard coda, modified coda is also decimal. You see modified coda as a decimal. And the question is, determine the hotel apportionment using Jefferson method. Okay, now listen, in the Hamilton method, what you did, whenever you find the standard coda, you lower down, right? In the Jefferson method also you lower down, modify coda. Okay, you lower down modify coda. Yes, exactly similar to Hamilton, you lower down. Let's lower down. 10.60 gonna be 10. 7.08 gonna be 7, and 18.72 gonna be 18. Okay, watch. Pretty much A got 10 surfboard, B got 7 surfboard, C got 18 surfboard. Are they divided? Is the apportionment going to be evenly here? Is that everybody has some number here? I mean, A has something, B has some number, C has some number. But if you add total, what is 7 plus 8 plus 10? 7 plus 8 plus 10. How much total are going to be? 35 total. See? Done. Nothing surplus. What happens is there is no surplus in Jefferson or or Webster or Adams, unlike Hamilton. Only Hamilton has surplus. But if you use Jefferson method, if you use modified divisor, no surplus. Exactly, the apportion is going to be divided among the group evenly. Therefore, no surplus is going to be there. That's the beauty of Jefferson method. No surplus. No surplus. In other words, if you use modified divisor, no surplus. This makes sense. Okay, Jefferson, lower down, modified coda. Find the modified coda, lower down. That's the Jefferson method. Okay. I want to mention something here for the homework, vocabulary section. I want to tell you this. Remember that we use modified divisor here, but we don't have to find the standard divisor. But if you find the standard divisor, you could, right? But I just want to point here, just like a note here, in this Jefferson method, modified divisor, a modified divisor is less than standard divisor always in Jefferson. Just want to mention that because in the homework might ask the question in Jefferson method. Okay. Okay. Number 6. Jefferson method. I'm not going to do that. Exactly same questions. Number 6 says this is the population of each country, or sorry, each state of the country. This total number of population. You don't have to find the total number of population since you are not using Hamilton. And this question, use Jefferson method. Use Jefferson method. You guys see that with the D. Listen here in the Jefferson, in this question number 6, modify divisor is 32,920. See, it tells you use D equals to 32,920. That's the modified divisor. Use that and do exactly same as question number 5. You're going to be fine. Okay, this is exactly similar question. You divide each group by this number and round down. That's the answer. Does it make sense what I'm saying? Again, you divide each group by this number and always round down because you lower down. That means round it down to the whole number. That's lower down. Okay. Question number 6 is similar. Therefore, I'm not going to do that. Question number 7. Question number 7. A small country with the population 6 million consists of 4 states A, B, C, D. There are 149 seats in the legislature that need to be apportioned among 4 states. Therefore, you guys see total number of item here going to be total number of item. Total number of item equals to 149, right? That's want to divide. Need to be apportioned, right? Need to be apportioned. Okay. Apportion. Need to be apportioned. Okay. Now, and the question tells you determine each state modify coda using divisor. See here in this question, modified divisor is given. Modified divisor is 40,700. Now let's find the modified coda for each group. Okay, you know how to find it. We did before. Modify coda for A. How do you find that? You divide come on modify coda for for A. How you do that? You divide A population 1241000 divided by 4700. Let's do the division. You guys check with me, okay? I'm going to divide by myself. You guys check with me. 1241000 divided by 40,700. Gonna get 30.49. 30.49. 30.49. Is that correct? 30.49. 271000 by 40,700. What do you get? You should get 66.58. If you have a different number, let me know, okay? If you divide C population by 40,700, you should get 21.67. If you divide D population by 40,700, you should get 28.67. Okay, that is called modified coda. Modified coda. Modified coda. You see the modified coda here? Modified coda. Everybody okay so far, right? Now, part B, we're doing Adams method. Okay, in Adams method, we do this. In Adams method, we round up. We round up. We round up. Unlike Jefferson, we round up here. In Jefferson, we round down. Do you guys remember that, right? Here, we round up to the nearest whole number, obviously. Therefore, this is going to be 30.41. Sorry, 30.49 going to be 31. 66.58 going to be 67. 21.67 going to be 22. 28.67 going to be 29. Therefore, this is the final apportion using Hamilton. This is the final apportion. Oh, sorry, not using Hamilton, using Adams method. And in other words, if you add all this number, 31 plus 67 plus 22 plus 29 must be 149. In other words, they has to apportion evenly without surplus. Therefore, an Adams method is still no surplus. Okay, that's the answer. Therefore, there is two parts of the question. One part of the question is find modified coda using the divisor, modified divisor, and then you round it up to the nearest whole number. That means round up, right? Doesn't matter whatever decimal part is, round up, and that is the final answer. You check it. 31 coda for A, 67 coda for B, 22 coda for C, 29 coda for D, altogether 149, finished. That is called Adams method. Any question? And part D, also Adams method. I'm not going to do that. Use Adams method, similar questions. I did the Adams method, just question number 7. Question number 8 is exactly similar. Okay, but I want to tell you something here for the quiz vocabulary portion. In Adams method, in Adams method, Adams method, modified divisor is slightly greater than standard divisor. for vocabulary question. That's what I say. For vocabulary, you should know that. Listen, if you look at the Jefferson, what I said in the Jefferson, modified divisor is less than a standard divisor. Okay, modified divisor is less than a standard divisor, but in Adams method, modified divisor is greater than a standard divisor. Okay, slightly greater than standard divisor, but just information for you guys. Okay, finally, last question number 9 here. That is called Webster method. Webster method. You guys see that? Let me make it bigger here. Webster method here, right? Webster method. Again, in this method, we use modified divisor, which is 29.6. And here, modified divisor is 29.6. Okay? That's given here. All right, now let's find the answer for each group here using Webster method. Webster method. Okay, let's write down the table back again here. Enrollment here. Enrollment here for introductory algebra, I put IA. For intermediate algebra, INTA, intermediate algebra. And finally, liberal arts math, LA, liberal arts, LAM, let's say liberal arts math. Okay, I put short form. What's the enrollment? 128, 273, 193. That is enrollment. And exactly we do the same thing as previous to method. We find modified coda. Modified coda. Okay, how do you find modified coda for A? Not A here, introductory algebra. 128 divided by 29.6. Let's do the math here. Okay, you guys double check with me. 128 divided by 29.6, you get 4.32. Okay, 4.32. That's the modified coda. For intermediate algebra, the modified coda is 273 divided by 29.6, 9.22. 9.22. For liberal arts math, the modified coda going to be 193 divided by 29.6, 9.6, 6.52. Okay, now final going to be final apportion. Therefore here you remember that in the Jefferson you round down, in the Adams you round up. Here you round regular rounding. Regular rounding. You know what do you mean regular rounding? Like normal rounding. Normal. You know how you round normally? 4.32 going to be 4. Right? Because of 32 is rounded to 4 as a whole number. As a 4. 9.22 rounded as a 9. 6.52 rounded as a 7. Okay. Now, if you add this number, total going to be how much? Total 4 plus 9 plus 7. Total 20. That's what it is. 20 section. Therefore, you see the question here. 20 section. And each section that offered here is for introductory algebra. 4 section is offered. Intermediate algebra, 9 section is offered. Liberal arts math, 7 section is offered. And you see total number of section that offer going to be obviously 9 plus 4 plus 7 going to be 20 sections. That's what we're going to be offered, and that's final apportion using Webster method. Therefore, what do you understand here? In Webster, you what kind of rounding you do? Normal rounding. Okay, in Webster you do normal rounding. Come on, Webster, you do normal rounding. Normal rounding. Okay, in Webster we do normal rounding, no surplus. Therefore, what you understood here is all this three method. Let me go back to the topics here. Okay, in this writing here, you see that okay, I wanna say here, okay, I don't have to realize this. In Hamilton method, you use standard divisor. Jefferson method, Adams method, Webster method, we use modified divisor. In Hamilton method, there is surplus. Jefferson method, Adams method, Webster method, no surplus. Adams method, you round it down. Sorry, Jefferson method, you round it down. Adams method, you round it up. Webster method, normal rounding. You guys see what I'm saying? That's what we understood so far in this section. All right, that's all about 13.3 apportionment method. Okay.